This video is the first of two on a topic called empirical formula. An empirical formula is the lowest whole number ratio of elements in a compound. For example, you could have C9, H15, N3, S6, O24, but this is not an empirical formula. All of the subscripts are divisible by 3. So for this compound, we would say the empirical formula is C3, H5, N3, S2, O8. So real quickly, I've got 4 examples coming up. Please determine if the formula given is an empirical formula. If it's not, figure out what the empirical formula is. And the first is sodium sulfate. And this is an empirical formula. The sulfur has a subscript of 1, so it can't be divided by anything to get a whole number. C8H12N6O4. This is not an empirical formula. Each of the subscripts is divisible by 2, so the empirical formula would be C4H6N3O2. How about C21H30O3? Once again, this is no. Each of the subscripts is divisible by 3, so this becomes the empirical formula. Last but not least is aluminum sulfate, and this is an empirical formula because you realize you've got 2 aluminums, 3 sulfurs, and 12 oxygens, and since 3 is a prime number, there's nothing that can be divided by to give another whole number except for 1. Now, if you happen to know the percent composition or the mass of each element in a compound, you can actually work backwards to calculate the empirical formula of that compound, and that's because of the law of definite proportions. And a way to remember this, a good mnemonic, is the percent composition poem. Percent to grams, grams to moles. Divide by small, multiply till whole. And actually the best way to interpret the poem is to dive right in and start solving some of these problems. I have 3 examples coming up, and here is the first. There is a compound that consists of 4 elements: carbon, hydrogen, nitrogen, and oxygen. The percentage by mass for each is given. What's the empirical formula for this compound? First thing to do is write down the 4 elements and write down what you know. We know the percentages. Now we can start with the poem. Percent to grams. Well, this is easy. Just take the percentage sign and change it to a G. Next, grams to moles. We know that grams divided by molecular weight equals moles. So we're going to divide each of these elements by their atomic masses to figure out how many moles we have. Please do note, when you do this calculation, carry it out to 4 decimal places. If you only carry it out to 1 or 2 decimal places, things can get messy. 4 decimal places. Now we're going to divide by small, continuing to go out to 4 decimal places. While looking at these 4 values, we see that 1.1349 is the smallest number of moles. So we're going to divide each of the numbers of moles by the smallest, and we get these values. Here's another important point. You need to look at the number in the 10th place. If that value is equal to 0 or 9, you can round to the nearest whole number. If it's not 0 or 9, you cannot round to the nearest whole number. Here we have 0, 0, 0, and 0, so these can all be rounded to the nearest whole number, 3, 6, 1, and 2. Now we need to see if we need to multiply those numbers to make them whole, and in actuality we don't because they are all whole numbers. So we would say the empirical formula is C3H6NO2. So now let's go to the second example. I'll have you do that one, get your answer, come back, check it, then I'll walk you through it, and I'm going to give you a hint. You don't always have to use every line of the poem. So here's the problem. You got a compound made up of carbon, hydrogen, chlorine, and oxygen. The sample contains 8.95 grams of carbon, half a gram of hydrogen, 17.61 grams of chlorine, and 7.94 grams of oxygen. What's the empirical formula? Go. And the answer is C3H2Cl2O2. How did we get this? Well, the first thing we did was write down in this case, 4 elements, carbon, hydrogen, chlorine, and oxygen, and we wrote down what we know about them. Then we went to the poem and went percent to grams. We're already in grams, so there's nothing to do. Skip this part. Grams to moles. remembering that grams divided by molecular weight equals moles. So we divide each of these by their atomic masses, and we get these values for the number of moles. Divide by small, 0.4960 is the smallest value there. Others are close, but they are a little bit larger. And so we divide everything by that, and then we notice that this value is not a 0 or a 9, so it cannot be rounded to the nearest whole number. And so we round them to these values, 1.5, 1, 1, and 1. Multiply till whole. Well, the carbon, if you multiply it by 2, becomes 3. That's a whole number. But whatever you do to one element, you must do to all the other elements. So they each get multiplied by 2, giving an empirical formula of C3H2Cl2O2. Now for the last example. You have strontium, phosphorus, and oxygen. The strontium is 58.05% of the compound. The oxygen is 28.27%. What's the empirical formula? Stop, get your answer, come back, check it, we'll walk through it. Go. And the answer is strontium 3, phosphorus 2, oxygen 8. Write down the 3 elements. Write down what we know about them. And now we can stop the poem. Percent to grams. And here you go, well, wait a second. We don't know the percentage of the phosphorus. But in actuality, you do. Because you know that the total percentages have to equal 100. So 100% equals the percentage of the strontium plus the percentage of the phosphorus plus the percentage of the oxygen. Plug in the appropriate values. Rearrange, and you realize that the phosphorus is 13.68%. So now we can convert to grams by changing the percentage sign to grams. Grams to moles, divide by the atomic masses, divide by small, which is 0.4417. So you do that and get these values, which round to these values, and obviously the strontium is not a whole number. So we're going to multiply till whole. 2 is the obvious candidate. And when we do that, we end up with strontium 3, phosphorus 2, oxygen 8. So to review, the empirical formula is the lowest whole number ratio of all elements in a compound. If you know the percent composition of the elements in the compound or the mass of each of the elements in the compound, you can work out the empirical formula. Don't forget the poem. Percent to grams, grams to moles. Divide by small, multiply till whole. Go do your worksheets. In the next video, we're going to work more with empirical formula using a slightly different setup.